I thought we'd take a look at the review sheet for midterm 1 and go through it together. So let's take a look at the very first question. We're going to find the domain of the following functions. The very first function is f of x equals the square root of x plus 1 divided by x. We look at that and we realize to be in the natural domain, the thing underneath the square root symbol needs to be non-negative, and the denominator cannot be 0. So let's write those two things down. So x plus 1 must be greater than or equal to 0, and x can't be 0. So if x plus 1 is greater than or equal to 0, that means that x is greater than or equal to negative 1. So these two things have to simultaneously be true. X has to be greater than or equal to negative 1, and x cannot be 0. Let's ask ourselves, which numbers are like that? Well, certainly everything between negative 1 and 0, including negative 1 but not 0. And of course also the numbers that are bigger than 0. I suppose if you wanted to leave your answer like this, that would be acceptable. Here we have it written in interval notation. You could have also written your solution in terms of sketching it on a number line. Let's take a look at the very next problem. So we're again supposed to find the domain of 2 over x cubed minus x. Again, we want to make sure that the denominator is not equal. Let's just see if we can make that a little bit clearer. There we go. We want to make sure that the denominator is not equal to 0. So x cubed minus x, we could say, is not equal to 0. Let's factor what's right there. So that makes it x times x squared minus 1 is not equal to 0. So x times x minus 1 times x plus 1 is not equal to 0. So x definitely can't be equal to 0. X can't be equal to 1. And x cannot be equal to negative 1. And let's take a look at the very next one. Here we want x cubed minus x to be non-negative. We can't have the thing underneath the square root being negative. We can certainly compare this one with the question that came immediately before it, which was part B, where we wanted x cubed minus x to be non-zero. So there's an obvious relation between these two questions. Let's go ahead and factor this again, even though we've already done it. So we have x times x minus 1 times x plus 1 greater than or equal to 0. To do this, we're of course going to create a sign chart. We could do it by algebra, but that would be a lot more work. So we'll just make a sign chart. So let's see. Minus 2, minus 1, 0, 1, 2, 3. We can see that this expression right here is 0 when x equals 0, and x equals minus 1, and x equals 1. And we've taken the real line and we've chopped it up into 4 pieces. So we can try a piece in each part. Let's just call this thing f of x. So let's try a part to the left of minus 1. So f of minus 2 is equal to minus 2 times minus 2 minus 1 times minus 2 plus 1, and that's equal to minus 2 times minus 3 times minus 1. 3 minuses multiply to give you a number less than 0. It's negative over here. And again, we'd plug in a number between negative 1 and 0. I'd probably plug in minus 1/2. We would plug in a number between 0 and 1. I'd probably plug in a half. You're going to find that it's positive here. You're going to find that it's negative here. And if I plug in a number to the right of 1, I'd probably plug in 2. You're going to find it's positive over here also. And so we're looking to see where this thing is greater than or equal to 0. So we're looking for the plus signs and the zeros. We can see plus signs and zeros between -1 and 0. We include the -1 and we include the 0 because this says greater than or equal to 0, and also everything to the right of 1. And there we go. Let's take a look at question number 2. Find the domain and range. We're going to start with the floor function. So it really helps to do this problem if you remember what the floor function looks like. Let's sketch ourselves a quick graph of this thing. Notice as we go through this, we're trying to show all our work. We're trying to justify all our answers. So we know that the floor function looks like stair steps. We want to make sure that that closed circle and that open circle line up, one right on top of the other. And this continues up in this direction, and it continues down in that direction. Now from that, we can remember what the floor function looks like, and that is one of the curves that we need to commit to memory. We can answer this question pretty easily. So the domain is a set of all x values which can go into this curve. So in other words, the set of all vertical lines which touch the curve somewhere. And I think you can see that every vertical line will touch this curve somewhere. Every vertical line will touch this graph somewhere. So the domain is all of R. Every real number, from -infinity to infinity. I could write it like this. I could write -infinity to infinity. It's up to you. You could write it out in words, all real numbers. The range is the set of y values which come out if I graph y equals the floor of x. Now you can see that there are plenty of y values that are not part of this curve. There's nothing at height 1/2, and there's nothing at height 1.5. There's nothing at height 1 3/4. But there is something at height 1, at height 2, at height 0, at height -1. These are the values in the range, all the integers, all the positive and negative and 0 whole numbers. So the range is all the integers. Remember, we use that symbol to mean integers. And you could write it like that, or you could write it out like a set. You could use, I need a little bit more space than that. So write it out in set braces, 0, 1, 2, so on, -1, -2, and so on in that direction. So every positive, negative, and 0 whole number, that's what's in the range of this function. So let's take a look at part B. G of x equals 3. Again, if you know what this curve looks like, this becomes an easy problem. So g of x equals 3, y equals 3 is just a plain old horizontal line at height 3. And so the domain is the set of x values which can go into this thing. Well, any x value can go into this thing. Any vertical line crosses this horizontal line somewhere. So the domain is all of R. And the range is a set of y values which come out. Well, there aren't really very many y values which come out. Only 3. That's the only y value which comes out of this thing. So the only y value in here is the number 3. That's it. Let's take a look at this one. Again, it helps to be able to see the graph of this thing. If we want to take a look at the graph of this thing, we can start by transforming a function that we know well. Let's start off with the function y equals the square root of x. We know y equals the square root of x. Looks like a half a parabola on its side. Let's do the x plus 1. We see that we are adding the 1 directly to the x. We know that's a horizontal change, and we know horizontal changes go opposite to the intuitive direction. So this is a shift. Adding 1's a shift. It's a horizontal shift to either to the left or the right. Plus 1, opposite to what you'd expect, 1 unit to the left. So minus 1, that's where it starts. And again, it's a half parabola on its side. Just shifted 1 unit to the left. Now we'll do the plus 2. We can see the 2 is added to the entire function. This is a vertical change. Vertical changes go in the direction that you think they do. So it's already moved 1 unit to the left. Now we're going to move it 2 units up. So it starts there at the point minus 1, 2, and goes off to the right. So we can see we started with y equals the square root of x. Here we have y equals the square root of x plus 1. That was shifted over 1 unit to the right. And here we have y equals the square root of x plus 1 all plus 2. And we see that that's the original curve shifted 1 unit to the left and 2 units up. So that's minus 1, 2. That's where the point which it starts. Now we can see the domain and the range of this easily. The domain, again, is all the set of x values which can go into this thing. Well, the x values start at minus 1, nothing to the left of minus 1, but they start at minus 1 and they go off to infinity. So the domain is going to be equal to minus 1 to infinity. And the range is the set of y values which can come out. Well, there's nothing down here at 0, nothing at height 1, but it starts at height 2, and then this curve keeps going up. So the range is going to be 2 to infinity. Let's take a look at the next question. Find the equation of the line perpendicular to y equals 2x minus 1 with y-intercept equal to 5. Well, if we're taking a look at this line, we can see the slope of this line is 2. We know that these two lines are perpendicular, so the slope of the line we want is in the negative reciprocal, so minus 1 over 2. And we're practically finished the question now. We know the slope, we know the y-intercept, so we can write y equals minus 1/2 x plus 5, and we're done. Now, let's sketch the function f of x equals the absolute value of x minus 2. So we'll start off with the function whose graph we know well. Y equals absolute value of x. And let's go ahead and shift it down by 2 units, which is what that minus 2 does. We can see that we're subtracting 2 from the entire function, not just from x. So this is a vertical change, if we can get it in focus here. Okay, so we shift the whole thing down 2 units. This goes down to minus 1, minus 2, and we draw on our V shape. I think that looks too steep. So we can see it crosses the y-axis at minus 2. This is y equals the absolute value of x minus 2. Now, if we're being asked to sketch a picture, I think it's probably fair to ask where this thing crosses the x-axis too. So let's figure out where these two crossings are. We know when we look for the x-intercepts, we set y equal to 0. So if I set y equal to 0, I end up with the absolute value of x minus 2 equals 0. So I end up with the absolute value of x equals 2. So x equals either 2 or minus 2. So these crossings occur at minus 2 and 2. So I think that's about all the information that anybody asking for a graph could possibly want. Now let's take a look at the second part. Now the second part, part B, is clearly related to the first part. All we've done to go from this function to this function is slap another set of absolute value symbols around the whole thing from part A. And we know exactly what that does. That takes the part of the graph that's below the x-axis and flips it up to where it's above the x-axis. So let me try to draw that. So this part of the graph stays the same. The part that's coming down to minus 2 stays the same, and the part that goes past 2 stays the same because that was above the x-axis before. But this part gets flipped up here. So we're actually going to have a W shape. This part goes up here. It's just as if we took this and folded the part below the x-axis up to where it was above the x-axis. And you end up with this W shape. Now let's take a look at part C. So we want to make sure that we can see that this thing crosses the y-axis at 2. It crossed at minus 2 before, now it crosses at 2. Still touches the x-axis at plus and minus 2. Let's take a look at part C. Is this function in part B odd, even, or neither? Well, it's odd if rotating it 180 degrees around the origin leaves it unchanged, but that's not true because then this one would be upside down. It would be an upside down W, I guess an M shape. And it's even if reflecting it over the line over the y-axis leaves it unchanged. So again, here's the x-axis, here's the y-axis, and I think you can see that if I do flip this curve over the y-axis, it's exactly the same. So this function is in fact even. So it's the same if we flip it over the y-axis. All right, let's take a look at number 5. There we are. So we're going to solve this inequality. X squared plus x minus 9 is greater than 0. And we're going to probably do that by using a sign chart. The only problem with this thing is it doesn't seem to factor. So if I take a look at f of x equals x squared plus x minus 9, and I try to factor that, we're going to find out it doesn't factor very easily. So we're stuck using the quadratic formula. Let's go ahead and set it equal to 0. So we'll set x squared plus x minus 9 equal to 0. So what we have here is our coefficients. A is equal to 1, b is equal to 1, that's the coefficient in front of the x, and c is equal to minus 9. So the quadratic formula, as you know very well, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's go ahead and do that computation. So negative 1 plus or minus the square root of 1 squared minus 4 times 1 times minus 9. Make sure it stays underneath the square root symbol. All over 2 times 1. So that's minus 1 plus or minus the square root of 37 all over 2. Now let's mark those 2 points on a real number line. So minus 1 minus root 37 over 2. You could either do this on a calculator or do it in your head. So 37, of course, root 37 is a little bit bigger than 6, so minus 1 minus a number a little bit bigger than 6 is a little bit smaller than negative 7, divided by 2, roughly minus 3.5. But again, you can do this on your calculator. So there's the number minus 1 minus root 37 all over 2. And the other number, minus 1 plus root 37 over 2, is going to be, since this number is a little bit bigger than 6, that's going to be, the top's going to be a little bit bigger than 5, a little bit bigger, so the whole thing's a little bit bigger than 5 halves, about 2.5. So minus 1 plus root 37 over 2. And we've effectively chopped the real line, so the whole thing is equal to 0 there, the whole thing is equal to 0 there. These are not open circles, those are zeros. That is where this function is equal to 0. But we've chopped the real line up into 1, 2, 3 bits. Let's just plug in one from each part. So I'll plug in one from to the left of minus 1 minus root 37 over 2. How about minus 4? So f of minus 4 is equal to minus 4 squared plus minus 4 minus 9. So that's 16. Minus 4 is 12. Minus 9 is 3, which is certainly greater than 0, so it's plus over here. And if we plug in 0, we see we get 0 plus 0 minus 9, it's negative. And if we plug in 3, we end up with 3 squared, that's 9, plus 3 is 12, minus 9 is 3, that's positive. And this says we are looking for where the whole thing is positive, not 0, so we don't include these 2 points, just positive. So we have plus signs to the left of minus 1 minus root 37 over 2, so that's everything from negative infinity to minus 1 minus root 37 over 2. Don't include the minus 1 minus root 37 over 2, and also everything to the right of minus 1 plus root 37 over 2. So minus 1 plus root 37 over 2 to plus infinity. Okay, let's take a look at this next one. In this next one, we have x plus 1 over x minus 1 is greater than 3. Let's get a 0 on the right side of the equation, on the right side of the inequality. X plus 1 divided by x minus 1 minus 3 is greater than 0. Now let's just get a common denominator, so x plus 1, x minus 1 minus 3 times, and I'll just multiply by 1 in the form x minus 1 over x minus 1 is greater than 0, and I can multiply this out. So x plus 1 over x minus 1 minus 3x plus 3 all over x minus 1 is greater than or equal to 0. And now I have two fractions over the same denominator, so I can go ahead, oops, can't see what I'm doing there, can you? So I have two fractions now over the same denominator, so I can go ahead and subtract them. So x plus 1 minus 3x plus 3 all over x minus 1 is greater than or equal to 0. And let me just continue up here. So x minus 3x is minus 2x, plus 1 plus 3 is plus 4, all over x minus 1 is, oh, I don't know where I got that greater than or equal to. That just says greater than, doesn't it? So greater than, 0. Now I'm all ready to do a sign chart. So we take a look at this fraction. We see the denominator, when the denominator is equal to 0, which happens when x equals 1, the denominator is equal to 0 means the whole fraction is undefined. So the fraction is undefined at x equals 1. Let's go ahead and see where the top's equal to 0. That will tell us where the fraction's equal to 0. So if minus 2x plus 4 is equal to 0, that means that minus 2x equals minus 4, or x is equal to 2. So at x equals 2, the whole fraction is equal to 0. Now I've chopped the real line up into 1, 2, 3 parts. Let me plug in a value from each part. If I plug in 0, I end up with 4 over negative 1. That's negative. And if I plug in 1.5, I will end up with, let's see, minus 3 plus 4 is 1, all over 1.5 minus 1. So they're both the top and the bottom are positive, so it will be positive here. And if I plug in 3, I'll end up with negative on the top, positive on the bottom, so it's negative over here. And this says I'm looking for the plus signs. Well, I see plus signs between 1 and 2. Carefully showing all my work. All right, now let's go ahead and sketch the function x squared minus x over x minus 1. Let's go ahead and factor the top of that. I can factor that as x times x minus 1 all over x minus 1. So we might feel tempted to cancel the x minus 1 on the top with the x minus 1 on the bottom, and I suppose I can kind of do that, but it's not, this whole thing is not defined if x equals 1. So this does equal x, but only as long as the denominator isn't 0. So only as long as x minus 1 is not 0. So x cannot be equal to 1. And at x equals 1, it's just not defined at all. So the graph, y equals f of x, looks just like the graph y equals x, which we know y equals x like the back of our hand. That's just the line which goes uphill at 45 degrees. It looks just like this, except at x equals 1, it is not defined. So it's that curve going up at 45 degrees, crossing at the origin, but there's a hole in the curve at x equals 1. And so there's our final answer. Find the domain and the range of this function. Well, the domain is the set of all x values which can go in, which is basically everything except 1. The domain is all real numbers except 1. I can write that as negative infinity to 1, and also everything to the right of 1. And the range is a set of y values which come out, which are also everything except 1. There's that hole in the curve at x equals 1. All right. Let's take a look at number 7. Find formulas for f plus g, f minus g, f times g, and f divided by g. This is going to be pretty easy. So f plus g is just f of x plus g of x. So write f of x, that's the square root of x. G of x is x minus 1 all over x minus 2, and put a plus sign in between. F minus g of x, same thing, square root of x, x minus 1 over x minus 2. We'll put a minus sign in the middle. That's supposed to be minus f times g, put the square root of x and the x minus 1 over x minus 2, and we'll just multiply those two things. And f divided by g, so square root of x divided by x minus 1 over x minus 2, probably the easiest thing we'll do all year. Now we're going to find the domain of each of these functions. Well, in part A, the thing underneath the square root has to be positive, so x has to be greater than or equal to 0. And the thing in the denominator can't be 0, so x can't be 2. So it's everything from 0 to 2 and everything past 2. So again, we want to make sure that what's underneath the square root is non-negative and what's in the denominator is not 0. So that's for f plus g. The domain of f minus g, same thing, exactly the same answer, 0 to 2, and everything from 2 to infinity. F times g, exactly the same. In f divided by g, this is the only one that gets even remotely interesting. You can see that we have a big fraction here, so the thing on the bottom can't be 0. So a fraction 0 where the top's 0, so this x can't be 1 either. So for f divided by g, it's everything that's non-negative, excluding 1 and excluding 2. So 0 to 1, and 1 to 2, and 2 to infinity. So we've excluded both 1 and 2. Now we're going to find formulas for f composed with g and g composed with f. So let me just rewrite f and g down here so you can see what they are. F of x equals the square root of x, and g of x equals x minus 1 all over x minus 2. And so if we have f composed with g, we have f composed with g, we have f composed with g of x is just f with g of x in parentheses. And so that's f of x minus 1 all over x minus 2. F of x is square root of x. F of box would be square root of box. So f of x minus 1 over x minus 2 is just the square root of x minus 1 over x minus 2. F just takes the square root of everything. Now g composed with f is g with f of x in parentheses. And this is equal to g of the square root of x. So g of x is x minus 1 over